Where's that toolbar? Huh. Huh. Oh well. Okay, here we go. So the last example, we were looking at the difference of squares pattern last time, right? So we talked about greatest common factor stuff. Remember, of course, that we always want to try to factor out the greatest common factor before we do anything. We're moving into next week. We'll look at how do we factor trinomials, and that's kind of a that's a little bit tougher. Probably the hardest part of our factoring review. But part 2 was difference of squares. So before we jump into this, can you guys quickly remind me, what is our difference of squares pattern? So if I have something in the form, a difference means I'm subtracting stuff, right? Squares are just things that are squared, okay? So we should get something like, we're starting off with something like that. A squared minus B squared, right? Where A and B are just things that are being squared. What's our pattern? How does that always break down? There you go. Okay, so if I have something squared minus something squared, it always is going to factor into the first thing minus the second thing times the first thing plus the second thing. Okay, every time. Okay, so we're trying to find ways. Oh, what happened here? Where's my? That's what I want. I'm going to erase this stuff. We're going to start over on this. So whenever we're faced with a binomial, and that's a word we'll use more in the future. But let me get everyone's attention up here real quick. I'll be done with it. This will only take probably 5 minutes, and then you can work. Anytime we get two terms that are subtracted, after we try to factor out the greatest common factor, if we're left with two terms that are being subtracted, something minus something, we always want to ask ourselves, does it fit that pattern? Could I write that as a difference of squares? Because if I can write that as a difference of squares, it's going to factor really easily, right? So can I? Can I take this thing here? Oops. Can I take this thing here, and could I write this as a difference of squares? Could I write this as something squared minus something squared? Well, the second part's pretty easy. 81 is what squared? 9. Okay, good. So that's 9 squared. What about the first part? Could I write 16x to the 4th as something squared? What would it be? 4x. Yeah, good. 4x squared, right? Good. Because we have a property of exponents here. We know that if I have something like a times b to the power of n, you might remember this from Algebra 1. If I have a product of two things taken to a power, that's the same thing as taking each factor to the power individually, right? So this is the same thing as saying 4 squared times x squared squared, right? And x squared squared is x to the 4th, right? Okay, so then good. We've got this other piece here. We could rewrite the 16x to the 4th as 4x squared quantity squared. So now that matches our difference of squares pattern, right? So this is like our A, and that's like our B. And so we know what the outcome is going to be then, right? We just get A minus B times A plus B. So instead of an A, our A is a 4x squared, minus, instead of our B is a 9. Are we good with that, everybody? Okay, so then we're down to here. So we've got this thing broken down into 4x squared minus 9 times 4x squared plus 9. So now when we're factoring, we always just have to keep asking ourselves, okay, am I done? Or can I break it apart further? Because when we're asked to factor something, what really we're being asked to do is factor it completely, break it apart as far as we can, okay? So Caleb, can you see anything else here that we could maybe do? We've broken this thing down from one expression into a product of two factors. That's good. We're breaking it apart. Can I break either of those factors apart anymore? Could I break them into smaller factors? Okay. Okay, good. So that first one, look, we've got this minus sign. I have something minus something. So once again, we have the question, could I take that first factor and rewrite it as a difference of squares? Okay. See if we can do that. So the second part's easy, right? I know I have my minus, and the second thing, a 9 is the same as a 3 squared, isn't it? What about the first piece? Okay, Caleb saw it. 4x squared is the same as the quantity 2x squared, isn't it? 2 squared is 4, x squared is x squared. Okay, and then the second one over here, what about this one? Does that fit any patterns? It doesn't fit a difference of squares, does it? The only pattern that it would fit is potentially it could fit the pattern a sum of squares, right? We could write it as 2x squared plus 3 squared. But what did we say about that the other day? Sum of squares is no pattern, right? Sum of squares does us no good. We can't do anything with it. So there's no sense in us even doing that, okay? Right, that's not helping us at all. We might as well just leave it as a 4x squared plus 9 because we can't break that one apart, okay? So we really should just, I'm even going to make a note of that. So we end up with, we'll do it this way. So here we've got our pattern. This is going to break apart into a 2x minus 3 times a 2x plus 3, isn't it? Hey, real quick, why did I put brackets there around that thing instead of parentheses? And I put brackets around this one too. Is it, okay, but like I had parentheses surrounding this. This is just a totally minor league question here. It's not a big deal, but I just want you to understand why I'm doing that. Because sometimes I'm putting myself in your position. You might be thinking, well, why do you put brackets there? It's just cosmetic, really, but how come? Yeah, to group the terms. Because now you realize that when I wrote 4 times x squared as something squared, I had to put that in parentheses, didn't I? Because the entire 2x is what is being squared. Everybody see that? So because I have to put that in parentheses, it's sort of visually confusing, at least to me, to see parentheses and then more parentheses. So the outer, I always like to change and write the inside grouping symbols as parentheses, and if I step out one, I make brackets, so it's easier to see that I've got quantities inside of quantities. Does that make sense? No other, I mean, those could be parentheses though, if you really wanted to. It wouldn't make any difference. So then this is going to break up into 2x minus 3 times 2x plus 3. Everybody agree? And this one, we can't do anything with that. That's a non-pattern. So we'll just leave that one the way it was. We'll just leave that as 4x squared plus 9 because we can't break it apart. And we're done. That's it. Now we can't go any further. This one can't go further because it's a sum of squares. And these are already down to the point where they're x's to the 1, and so we can't go any further than that. Okay? Thumb up, thumbs down, thumb sideways. How we doing? Okay. All right. Get working.